Today we focused on one-step inequalities in class, and we learned a number of important rules that helped us to make sure that we were both solving and graphing one-step inequalities correctly. And so I'm going to do a couple of examples, both on the front side and on the back side, to help refresh your memory. And then hopefully the key will also give you a good refresher as you're working through your solutions this evening. So problem 18 tells us to graph the inequality on a number line. And since I'm graphing b is less than or equal to 1.5, I'm going to go ahead and do some hash marks. And let's go with 0, 1, 2, 3. And I know that 1.5 is right smack in the middle between 1 and 2. And then I'm making a less than or equals to graph. And since less than is everything below 1.5 and equals to means that 1.5 is an included value that makes my statement true, I'm going to put a closed dot or a filled in dot, and then I'm going to try to highlight my line to the left so that it indicates that these are all now included values less than 1.5 or lower than on the number scale, and give it some sort of arrow that indicates the direction of travel. C is less than 17. This one will be very similar. I'm going to start at 15, 16, 17, 18. And C is less than 17. So 17 is not an included value, but I need to reference 17 as the starting point. And so when we're doing that, we simply put an open circle. That open circle represents 17 as the starting point, but not being an included value. It's only an included value if the circle is filled in. And again, it's all of the values less than 17, so moving towards 0, and give myself an arrow. I also wanted to do a couple of problems on the back just to make sure that we were familiar with how to solve these problems based on what we did in class. So 3/4 b is less than 18. And we need to solve the inequality. So just like we did last week when we were solving equalities or equations, we need to get our variable all by itself. So 3b is less than 18. The first thing I would do here is multiply my fraction by its reciprocal. I did not do reciprocal. By 4 over 3. Because now my 3's will cancel each other out and my 4's will cancel each other out. And anything I do to one side of the equation, I have got to do to the other. And since I like to be a good math student and simplify, I will know that 3 goes into 18 6 times. 3 goes into 3 one time. And then 6 times 4 is 24. So now take all of our pieces of information. Our b we got by itself, drop down. Since we didn't multiply or divide by a -1, we simply drop down our inequality sign. And then the value that we determined the right side of our equation to be, 24. So for this problem, b is less than 24. Now we want to be able to use some of that information, so the last 6 problems had us practicing not only solving for the variable, but also graphing the variable. So we're going to start with problem 29. -4x is less than or equal to -16. And so again, just like when we were solving equations last week, we want to get the variable all by itself. I will divide by -4, divide by -4 on the other side, Negative 4 divided by negative 4 is 1, so that will give me 1x, or we can just call it x. Negative 16 divided by negative 4 is now a positive 4, because a negative divided by a negative is positive. And any time that we divide by a negative term in an inequality statement, we need to remember to flip the sign. Unfortunately, it's just one of those rules. That's our new big piece of information that I had you highlight, star, make notation of, and we kind of reinforced heavily in class. So I'm going to flip the inequality sign, and now our solution tells us that x is greater than or equal to 4. Well, we can graph this on a line. And since we're using the greater than or equal symbol, again, we know that we need to have a filled in circle on the value 4. Now our expression says x is greater than or equal to 4. Well, there's multiple ways to do this. Our one strategy is to kind of take the shortcut hint. Our inequality symbol is pointing to the right, so we will fill in all of our values to the right. And if you've forgotten that, another way that you can graph this is to identify terms for this variable that make the statement true. So if I were to say 4 is equal to or greater than 4, that would be true because 4 is equal to 4, so that would be an included value. 5 is greater than or equal to 4. Yes, it is greater than, so that would be an included value. 6 is greater than 4. That would be an included value. So we know that as we continue to progress towards the right on our number line, all of those values would be included. And so that's where we would make our line indicated. We can also check the negated term by looking at 2. So if we plug 2 in for x, the statement would say 2 is greater than or equal to 4. And that's not true. So since it's not true, there should not be any shading anywhere near 2. Check again for 1. 1 is greater than or equal to 4. Well, that's not true. So we shouldn't shade down here next to 1. And that's how you can check your answer by plugging in terms on your number line. Number 30, 15 is greater than x minus 1. One of the rules we learned is that we want to keep our variable expression on the left side. So I'm going to move it over here. And anytime you move the order of the terms or the expressions, you also flip the sign. So in essence, nothing's really changing. I want the open portion of my inequality sign to be facing the 15. Well, I have my x minus 1 and I have my 15 here. So the open portion is now again facing the 15 and the pointed portion is now facing the 1. So I now have my variable on the left side of the inequality term, my solution on the right side of the inequality term, and everything is pointing exactly where it needs to be. Next step would be to add 1 to both sides of this inequality. And so when I add 1 to negative 1, that gives me 0, so that will cancel out and drop down an x. I'm not multiplying or dividing by a negative term, so my sign will stay in the exact same position. And then 15 plus 1 is 16. So x is less than 16. Again, we can graph this, and I'm not going to need as many notches. 14, 15, 16, 17, 18 should do. And x is less than 16, but x is not 16 itself. So I'm going to have an open circle to represent that that's my starting value, but that 16 is not included. And then every term that is less than 16 satisfies as an included value for this inequality. And again, we could check that numerically. Negative 14, 14, if I plugged 14 into x, 14 is less than 16. Is that statement true? Yes. Well, that should be shaded on my number line. 18, if I plug 18 into x, 18 is less than 16. That statement is false, so it should not be shaded. Just a quick way to check your answers numerically.